Hello juniors, today we're going to continue with the first topic of the IB that we're covering for math, which is about functions. And we're going to start with two new functions which are related to each other, which are exponential functions and logarithmic functions. So to begin with, we're going to start with the exponential function, and we're going to start with the basics, which is, first of all, defining what an exponent is. So this is electronic assignment 36, exponents. The objectives for the class are two. Number one, solve exponential equations, and number two, interpret and apply laws of exponents. Okay, so let's start by defining what the exponent is about. It says, exponents are a shorthand way of representing the repeated multiplication of a number by itself. The expression 3 to the power of 5, for example, represents 3 times 3 times 3 times 3 times 3. The 3 in this expression is the base number and the 5 is the exponent. Other names for exponent are power and index. Okay, so here you have a summary of what I just read. The number in the bottom is always known as the base, and the exponent is known as I said, the exponent, power, or also index. Okay. So it says you can also use a variable as the base. For example, x to the power of 4 is the same as multiplying x 4 times. Okay, now we're going to see 7 laws of exponents, which are very important for you to know. I've seen lots and lots of IB exercises where these laws are to be applied. And these laws are not in the formula booklet, so these are laws that you should know, okay? So the first law is multiplication. It says, as an example, simplify x to the fifth power times x to the cube power. If we have a multiplication of two numbers with the same base, the exponents add up each other, right? And here you have the demonstration of why that occurs, right? If we multiply x 5 times and multiply that by 3 by x, which is multiplied 3 times, then we're going to get 8 x's, so this is the same as x to the power of 8. So whenever we multiply two numbers with the same base, the exponents add up each other, right? 5 plus 3 is 8. So this is a general rule. A to the power of m times a to the power of n is equal to a to the power of m plus n. It says, notice that x to the fifth power times x cubed, the two base variables are the same. You cannot simplify x to the fifth power times y to the cube power, for example, using this law. Okay, so that's a common mistake. If they are not the same base, then you cannot apply this property. Number two, division. Well, this is exactly the same as multiplication, but the other way around, right? If we have, for example, x cubed divided by, x to the fifth power divided by x cubed, this is writing x 5 times as in the numerator, x 3 times in the denominator. We simplify 3 x's, as you can see here, and we're left with only 2. So this is equal to x squared. So x to the fifth power divided by x cubed is the same as subtracting the exponents, x to the power of 5 minus 3, which is x squared. So as a general rule, a to the power of m divided by a to the power of n is a to the power of m minus n. Once again, notice that you can't simplify x to the fifth power divided by y cubed because the bases are not the same. So the bases must be the same in order to apply these rules. Rule number 3, raising to a power. X, and as an example, x to the power of 5 to the power of 3 again. If we have this case, how do we express this? We need to write this expression 3 times, right? 5 times x, and we write that 3 times. So in total, we're going to get 15 x's if you count all of this. So the result is x to the power of 15. So if we have x to the fifth power to the cube power again, then we multiply the exponents and we get x to the power of 15. So as a general rule, a to the power of m to the power of n is equal to a to the power of m times n. Okay, so there's an example here. It says, example 1, expand 2 times x times y squared and all of that to the cube power. So how do we do this? In this particular case, the 3, we distribute the 3 among the 3 terms because it's affecting all of the terms because they are all inside the parentheses. So this would be equal to 2 cubed times x cubed times y squared, which is being cubed again, right? So this is the same as 2 cubed, that's 8, x cubed, that's x cubed, and y squared cubed is y to the power of 2 times 3, which is y to the 6th power. Okay, these are easy examples just to warm up. Okay, then we have the fourth rule, the fourth law, which is the power 0. Have you ever wondered why any number, let's say a, to the power of 0 is always equal to 1? If you ever wondered that, or if you never really understood why, now you should be able to understand why that occurs. Let's see. As an example, imagine x squared divided by x squared. According to the second rule, this is x squared divided by x squared, and we need to subtract the exponents, right? So x to the power of 2 minus 2, 2 minus 2 is equal to 0, right? So x to the power of 0. But we know that if we divide one thing by itself, for example, 5 divided by 5, that is always equal to 1, right? One thing divided by itself is always equal to 1. That means that x squared divided by x squared is equal to 1, but we also know that x squared divided by x squared is x to the power of 0 according to the second law, right? Therefore, x to the power of 0 is equal to 1, okay? So as a general rule, any number to the power of 0 is equal to 1. Any base raised to the power of 0 is equal to 1. And this as a reminder, 0 to any exponent is always equal to 0, except 0 to the power of 0, which is something that we call undefined, but we're going to see that, or maybe you're going to see that later on in the university, so don't worry about this. So 0 to the power of any number except 0 is always equal to 0. Rule number 5, fractional exponents. Example, simplify x to the power of 1/2 times x to the power of 1/2. So if we use the first law, we can add the exponents. So this is x to the power of 1/2 plus 1/2, which is 1/2 plus 1/2 is 1, right? So this is x to the power of 1. And we also know that the square root of x times the square root of x is the same as the square root of x squared. That means that the square root sign simplifies and we just get x, right? So then we can conclude that the square root of x is equal to x to the power of 1/2 because we get the same result, okay? Similarly, we can do this and we're gonna get x. So the cubic root of x is equal to x to the power of 1/3. So, as a general rule, what we have here in red, the nth root of a is equal to 1 over n. So it's always the exponent I have inside here, in this case it's 1 because there's no exponent, in the numerator of the fraction divided by the index of the radical, right? In this case, n, okay? So the rule number 6 is just an extension of rule number 5, which is applicable for any exponent inside the radical, right? So if we, for example, have x to the power of 6, the cubic root of x to the power of 6, we know that this is equal to x to the power of, and in fraction form, 6 divided by 3. It's always the number inside as the numerator and the number outside as the denominator, okay? So that's the general rule. Here you have, and I'm gonna write it here using small. This one goes in the numerator, and this one, and this one goes to the denominator. Right? Numerator is the one on top, denominator is the one below. Okay? So that's the general rule for any type of root. Super. So let's move on to the following example. It says, without using a calculator, evaluate, and there you have 36 to the power of 1/2 and 1 over 27 to the power of 4/3. Okay, so without using a calculator, how can we evaluate this? First of all, we know that 36 to the power of 1/2, we can rewrite this as, we know that this is the square, this is the index of the square root, and this is the exponent inside of the square root. So this is the same as saying the square root of 36, right? And the square root of 36, we know that it's either plus or minus 6. Okay, so that's the result for this first case. Or another way of solving this, let me do this as an alternative, or we could say that 36 is equal to 6 squared, right? So if we, instead of writing 36, we write 6 squared, and we put this to the power of 1/2 because it's to the power of 1/2, then this is the same as, in this case we have a power to another power, so we need to multiply the exponents, and we're going to get 6 to the power of 2 times 1, that's 2 over 2, right? And 2 divided by 2, that's 1, so this is 6 to the power of 1, and 6 to the power of 1 is 6, okay? So this is another way of solving the same situation, right? Okay, so let's see then part B. I'm going to separate this using a line. Part B says the following: 1 over 27 to the power of 4/3. Okay, so 1 over 27 to the power of 4/3. One way that we could do this is, for example, we can convert 27 to its equivalent, which is 3 cubed, right? We know that 27 is equal to 3 cubed. So we can rewrite this expression over here as 1 over 3 cubed to the power of 4/3. Now, as this 4/3 is the exponent, we can distribute, or we can multiply this exponent by each of these terms over here, right? The exponent is distributes among the numerator and the denominator. So this is the same as saying 1 to the power of 4/3 divided by 3 to the cube power, which is again multiplied by 4/3, right? So 1 to the power of any number is always equal to 1, okay? So this is always 1, independent of the value of the exponent. And here we have a power to another power, so we multiply the exponents, and we're going to get 3 to the power of, both 3's simplify, right? This is 3, let me write this here, 3 times 4 over 3. I'm going to do this a little bit smaller just to avoid confusion. So this is 3 times 4 over 3, right? So you see that the 3 actually simplifies, and we're going to get 1 over 3 to the power of 4. And 3 to the power of 4 is 27 times 3, which is 81. Okay, so this is equal to 1 over 81. So this is how we solve this without using a calculator. Okay, there's another way of solving this, but let's see. This could get a little bit more messier, but let's see. So another way, or we could say that since this is to the power of 4/3, we can rewrite this as the cubic root of 1 over 27 to the 4th power, right? By using the root law. I'm gonna make this a little bit smaller. So to the 4th power, there. Okay, so once again, we can rewrite the 27 as 3 cubed. So this is 1 over 3 cubed, and all of this is to the 4th power, right? Okay, so now we can distribute the exponent, 1 to the 4th power and 3 to a cube power to a 4th power. So we would get as a result the cubic root of 1 to the fourth power, that's 1. And here 3 to the cubic power to the fourth power, that's 3 times 4, which is 12. So 3 to the 12th power. Okay? So if we take the cubic root of 3 to the power of 12, remember we need to divide the exponents in this case. So 12 divided by 3 is 3 to the power of 4, right? And the cubic root of 1 is always equal to 1. So this is 1 over 3 to the fourth power. And 3 to the fourth power is 81. So this is 1 over 81. So you see that we get exactly the same result. This is another way of solving this. Okay, let's move on to another property, another law, which is negative exponents. It says, simplify x cubed divided by x to the power of 5. So what do we get? 3x's on top and 5x's below. So if we simplify 3x's here, we're going to be left with 2x's in the denominator. So this is equal to 1 over x squared. Also, from the, I think it was the second property, we know that x cubed divided by x to the power of 5 is the same as x to the power of 3 minus 5, which is equal to x to the power of negative 2. That means that x to the power of negative 2 must be equal to 1 over x squared. And this is a very important law, which is that if I have x to the power of negative 2, I can turn this exponent to a positive number, but taking it to the denominator. Okay, so x to the power of negative 2 is equal to 1 over x squared. So as a general rule, a to the power of negative n is equal to 1 over a to the power of n. Okay, so here you have the observation I told you at the beginning. Observation, there's a mistake here, right? Observation has only one t. Oops. Observation. There you go. Observation. So it says you must learn the laws of exponents as they are not in the formula booklet. So this is something you must know. Okay, so let's see example 3. It says without using a calculator, evaluate 6 to the power of negative 2. So 6 to the power of negative 2. From this law over here, we know that that is the same as saying 1 over 6 squared with a positive exponent. So we know that 6 squared is 36, so this is 1 over 36, and this is the result. Okay, then for part B, it says 3/4 to the power of negative 2. Once again, we can do this. Okay, I'm going to distribute the negative 2, so this would be equal to 3 to the power of negative 2 divided by 4 to the power of negative 2. And once I have done this, I can change the position of each because they have a negative sign, right? So I can take the 4 to the numerator and the 3 to the denominator. So this would be equal to, let me do this here, this would be 4 squared divided by 3 squared. 4 squared is 16 and 3 squared is 9. And we cannot simplify this, so this would be our final result. Okay? I hope this is being clear. Let's move on. I think this is the last part. Yes. Example 4. We're going to see some exercises where we need to apply multiple laws. So here it says simplify these expressions. And here we have simplify means write this expression using only positive exponents. So that's what the word simplify means in this particular set of exercises. Okay, so part A, we have 5 times d to the power of 0. As we said in one of the first laws, I think the third one, any number to the power of 0 is always equal to 1, right? So one thing you need to pay attention here is that this power of 0 is only affecting the d. It's not affecting the 5. If it affected the 5, it should have been written in parentheses, okay? So as it is only affecting the d, this is 5 times 1, and 5 times 1 is equal to 5. So this is the result for part A. Then we have part B, which says let me write this here, 6 times x to the power of negative 3 divided by, parentheses, 2x squared cubed. Okay, so we need to work with this. The first thing we can do is write this using the other way of dividing, using this notation. It's more comfortable. So this would be equal to 6 over x cubed, if I take the x down because it has a negative exponent. And this is being divided by 2x squared to the cube power. So if we distribute the cube, this would be 2 cubed times x to the power of 6, right? So this would be 2 cubed, that's 8, times x to the power of 6, right? Okay, and this is over 1. It is not being divided by anything, so we can write this as over 1. So here we can, we have a fraction over a fraction, so to solve this we need to multiply top with bottom and middle with middle. So as a result, we're going to have, this would be equal to 6 times 1, that's 6, divided by 8x to the 6th power times x cubed. In this case, we need to add the exponents of the x, so we're going to get 8x9. Okay? We can simplify the 6 and the 8, and we're going to get as a result, this is 3, this is 4. So the final answer would be 3 over 4x to the power of 9. This would be the final result. Okay? Now let's see exercise C, which is 27a to the 6th power, and this is into a cubic root. Okay, so to solve this, we can, well, we know that 27 can be rewritten as 3 cubed, right? Times a to the power of 6, and this is to the cubic root. So the cubic root of 3 cubed would be 3 directly. So this is 3. And a to the power of 6, the cubic root of that, remember we need to divide the exponents. So 6 divided by 3, that's 2. So this is 3a squared. And that will be the result for part C. Finally, exercise D says 9v squared over 9v squared over 16w to the 4th power, and this is all to the negative 1 to negative 1/2. Okay, so the first thing I see we can do is, since this has a negative sign, then I can change the order of this and say that this is the same as saying 16w4 divided by 9v squared, and this is all to the power of positive 1/2, right? Because I flipped the numerator and denominator. Now, to the power of 1/2 is the same as saying the square root of all this, right? So I can write this as 16w4 divided by 9v squared, and all of this square root, right? And this is almost solved already. Now I need to take the square root of all of the terms, and we're gonna have the result. The square root of 16, that's 4. The square root of w to the 4th power, that's w to the 2nd power, because it's 4 divided by 2, over square root of 9, that's 3, times the square root of v squared, that's 2 divided by 2, which is 1. So this is 3b. And that is a result. This is a result. And I think that's it. Yes, that's it. So I hope this was clear enough for you, juniors. We're going to be practicing with this in the following classes. So please let me know if you have any doubts about this. And thank you for your attention. See you.